Hi everybody. So on today's show we're doing things a little bit differently. You're learning at home and then coming into class and practicing with me and with your classmates. So on today's show we learn how to solve linear systems that contain 3 equations and 3 variables. This is lesson 8 in your book, so make sure you're following along and writing in there. So we begin. First of all, you should have went to Google Classroom and got the link to the Desmos activity. Otherwise, you wouldn't be watching this video. So check. As an opening exercise, we're going to solve the following linear system using elimination from 8th grade in Algebra 1. So at this point, pause the video. If you remember elimination, great. Pause it, see if you can do it. If not, I'm going to do it right now. So now's your chance to pause. So how do I solve this using elimination? When we use elimination, our goal is to rig the system here so that when we add them together, a variable eliminates. Right now, if I was to add these two equations together, I would get 5x plus 3y equals negative 16. I want to eliminate one of those variables. So the way that we do that is we use the multiplication property of equality. We multiply one of the equations, we scale it up so that we have inverses. So if I had a 3 here, I would want a negative 3 here. If I had a 2 here, I'd want a negative 2 here. So I'm going to multiply that bottom equation by negative 2. That way, when I rewrite the system here, the top equation I didn't touch, I now get negative 4x minus 2y equals positive 14. Now when I add these two equations together, when I add them together, my y's add to 0, and I'm left with negative 1x equals positive 5. So if negative 1x equals positive 5, x equals negative 5. However, we haven't solved a system. When we solve a system, we're looking for an ordered pair x comma y that makes both of them true. So we plug back in. We plug back in for x. Doesn't matter which one you pick, you're going to get the same answer. 2 times negative 5 plus y equals negative 7. Negative 10 plus what gives me negative 7? We'll add 10 to both sides and you get y equals 3. So the solution to the system is negative 5 comma 3. Hopefully that was review. If you eliminated the x's, you would have to multiply the top one by 2 and the bottom one by negative 3. One of them had to be negative so that they add to 0. Hopefully this isn't something that scares you, because this should be quick and easy. Because now we're going to look at something on the next page that looks a little bit scarier, but luckily we're just going to do the same thing over again. Now, some of you are saying right now, like, Coach, what is this? Don't worry, we're going to talk about it. So solve the following system of equations. This is a system where we have 3 equations, clearly there's 3 of them, and we now have 3 variables, x, y, z, because after x and y, clearly we have to use the variable c. That's what us mathematicians do. So this is a 3 by 3 linear system is how I'll refer to it, because there's 3 equations with 3 variables. And we're going to use elimination still. So the process is pick 2 equations and eliminate something. So the first thing that we're going to do over here is we're going to pick 2 equations and eliminate something, just like we did in the opening exercise there. And looking at this, you should be saying, you know what, Coach, those z's look pretty good. Z, negative z. When I have a z and a negative z, when I add those two together, so if I work with those first 2 here, I don't know what happened there. If I add those first 2 equations together, what happens? That's our first step, is add 2 equations together to eliminate something. So 2x, I'm just going to rewrite them, plus y plus z equals 15. And 6x minus 3y minus z equals 35. So look at those z's right there. When I add these 2 equations together, they're going to eliminate. I get 8x minus 2y, the z's eliminated, equals 50. That was the first step. We eliminated one of the variables. We eliminated z. So over here now, we're going to pick 2 different equations. Pick 2 different equations. Eliminate the same variable. We eliminate the same variable. So I got rid of z over here. When I pick 2 different equations, I still have to get rid of z. So it looks like I'm going to pick 1 and 3. Why? Because when I add 1 and 3 together, my z's are going to eliminate. So I'm just going to rewrite the equations. That's the first one. I'm going to do the first and third this time. I still have to get rid of z. And what happens when I add those two together? I get negative 2x plus 5y. My z's eliminate, they add to 0, equals 1. Great. So the next step now is it's an Algebra 1 problem. The next step over here is you now have an Algebra 1 problem. You have that equation and that other equation. It's only two variables in them. There's only two variables there, x and y. And we solve this system just like we did in the opening exercise. We use elimination. So once we get to this piece down here, this is Algebra 1. So the top part was Algebra 2. You had to know what to do there. Now it's an Algebra 1 problem. We solve that. How am I going to eliminate stuff? I think I'm going to multiply the bottom one by 4. So I get 8x minus 2y equals 50. I didn't touch that. And then what do I have down here? I have negative 8x plus 20y equals 4. I'm going to add those together now, and I get 18y equals 54. And I believe when you do 54 divided by 3, sorry, when you do 54 divided by 18, you get 3. So we get y equals 3. When we solve this system of equations, this Algebra 2 problem, this 3 by 3, we're looking for x, y, and z. We're looking for all three, x, y, z, that ordered triple there. So we got y. We plug back in. We plug back in to the Algebra 1 problem. I'm going to pick the top one. 8x minus 2 times 3 equals 50. 8x minus 6 equals 50. 8x equals 56. Divide by 8, and you get x equals 7. Great, so you've got y and you've got x. I now need to get z. And the way that we do that is we take both of these answers and plug them into one of our original 3 by 3 equations. Pick one, it doesn't matter. The first one looks the easiest. 2x, 2 times 7 is 14. Let me write that out because it's the first example I've done. 2 times 7 is 14, plus y is 3, plus z equals 15. So 14 plus 3 plus z has to give me 15. That's 17 plus z equals 15. Well, 17 plus what gives you 15? 17 plus negative 2. So z equals negative 2. Make sure your z's do not look like your 2's. That's why I do 2's with the loops at the bottom of them, because my z's would look like 2's otherwise. So what's my final answer? You can leave it like that, y, x, and z. It doesn't hurt to write it in order. X equals 7, y equals 3, z equals negative 2. That's one way you can write your final answer. Or you could do an order triplet of 7, 3, negative 2. Either way, that works. So that's how we solve 3 by 3 systems. I forgot to number the other steps here. This was step 4, and this was step 5. I'm gonna be a stickler for the way you do these because they can get messy. When you do these problems, follow this order. Start in the upper left-hand corner, then go to the upper right-hand corner, then work across 3, 4, 5. I'll do another practice problem, and then I'm going to let you do it on your own. So I'll see you in the next video. Let's try one more 3 by 3 system together before I let you try one on your own. So I ask you to solve the system of equations for all values of x, y, and z. So I want to know what values of x, y, and z make all three of these equations true. So we're going to use elimination. Make sure that your x's are all lined up, your y's are all lined up, and your z's are all lined up equals some number. Make sure it's set up in that way, otherwise it's going to be a little bit more difficult to solve these problems. So looking at these, what variable do I want to eliminate? Well, in the last one we got lucky because those z's eliminated right away. Well, wait a minute, I see that these guys can be eliminated, those y and minus y. So the first thing we're going to do is let's add those together. 4x plus y minus 3z equals negative 6. And then 5x minus y minus 7z equals negative 19. We got lucky there that those y's matched up, because when I add them together, they add to 0. So I get 9x minus 10z equals negative 25. Our second step over here is I eliminated y, I need to eliminate y again. Eliminate y again. So I need to pick a different two equations. Well, there's nothing that's really going to add to 0 when I smush them together. So what we have to do is we have to scale equations up. Just like we do when we solve 2x2 systems, we're going to multiply everybody in that equation by the same number. So I picked the second and third because I like that negative y with that 4y. So I need to somehow make that last equation there have a negative 4y. So what I'm going to do is I'm going to multiply it by 4. So I get 20x. I have to distribute it to every term. Minus 4y minus 28z equals 19 times 4 is going to be negative 76. So we scaled up everyone in that equation. I made the equation look different, but it's still the same equation. So now I can eliminate y, and I get 18x minus 26z equals negative 38. Now I've got an algebra 1 problem to solve. Come down here and solve the algebra 1 problem. 9x minus 10z equals negative 25. And 18x minus 20z equals negative 38. Again, it's very easy to make mistakes on these problems. Conceptually, you might be able to do it, but you miss a negative sign, you add two numbers wrong. Please, please be careful here. Well, it looks like I'm going to have to multiply that top equation by negative 2. So I can eliminate that 18 there. So my new system becomes negative 18x plus 20z equals 50. I'm not going to rewrite that bottom one again. I just multiplied that by 2 there. Those add to 0. I'm left with negative 6z equals positive 12. Divide by negative 6 and get z equals negative 2. Great. Now we plug that back in. Doesn't matter which one you choose. I'm going to go with 9x minus 10 times negative 2. You might be able to do that step in your head, by the way, to save yourself some time. 10 times negative 10 times negative 2 is positive 20 equals negative 25. Subtract over that 20. We love solving two-step linear equations. If only we could go back to 7th grade to do this all over again. We get x equals negative 5. We're not done yet. Our final step now. Our final step is to take both of those values and go return to the algebra 2 problem. You've got z and x. Plug it into any of the equations. I'm going to go with the first one. 4 times x is negative 5, plus y, we don't know what that is, minus 3z. Careful with all these negatives here. Negative 20 plus y plus 6 equals negative 6. Well, negative 14 plus y needs to give me negative 6. Add 14 over and get y equals 8. So, what's the solution? Solve the system of equations for all values of x, y, and z. The solution is, if you write them just out, x equals negative 5, y equals 8, z equals negative 2. There's my solution. Or if you wrote it as an ordered triple, doesn't matter, negative 5, 8, negative 2. Either one of those represents the solution set of this system. If you pick any of those values, you can plug them in and you're going to get 3 true statements. See how I use that same structure again. Pick 2 of the equations, added them together. Picked another 2 of the equations. This case, I had to multiply one of them. You might have to do that, but twice. You might have to, so be prepared for that. Put that over here. And then I made an algebra 1 problem in this bottom left corner. Solved for one of the variables. Plugged it into the algebra 1 problem and got the second variable. And then the final step, this bottom right, is taking both of those values and plugging them back into the top. Get fast at these. That's what we're going to practice in classes. I didn't want to spend class doing this for 45 minutes. I want you practicing. So you have an OYO on the next page. Try it out. And I'll see you in class.